Thanks. So good evening. Like every year, it's an honor and a privilege to be here. It's a little bit cooler this year than it was last year. I noticed that, but I'm sure the show's going to be hotter than it was last year. It always is. Before I get started, I notice there's a number of laptops up, busily taking notes. But before we get there, I wanted to ask how many people today were rooting for Spain versus Australia? Okay. How many people are rooting for the Netherlands versus Chile? All right. So well, I will try to do my best at the halfway point to see if I can get you a score update. Or judging by the number of people that have laptops open, maybe you can give me a score update. So that said, I wanted to take this time primarily for a couple of things. One is for us to thank the community for their help, for their collaboration, for yet another wonderful year in HPC. As you will see, as an HPC fraternity, as an HPC industry, we've made some tremendous progress working together. And we are on the doorstep of some very interesting changes coming up going forward. The second thing, of course, was to do a little bit of a retrospective, this being the 20th year of the Beowulf cluster, the architectural approach that democratized HPC in some sense from the big machines that only a few could even touch and see, to something that many, many more could afford to own, and more importantly, a community that could learn to program and write code for it. So we'll do a little bit of that, but hopefully out of this conversation, you'll get a good sense of Intel's perspective of where the exciting future lies and what we are doing to get there in partnership with the larger community. So this being the day the top 500, the June list gets announced. It was announced this morning somewhere when I was over Iceland, I think, or Greenland, flying over here. And it's, again, quite instructive to look at the trends in addition to the results of this year. So if you look at the top left chart, and if I'm seeing this correctly, the first thing that catches your eye is the number of new systems on the list. And if you look at it carefully, the red and the blue lines, which is the number of new systems and the number of new systems based on Intel, this year kind of almost merged. The fact that they go up and down depending on how many systems get introduced, which is more a development and funding cycle related issue rather than a technology related issue sometimes. But at the end of the day, the red and blue lines have merged quite well over the last 2 years or so. And if you see that, that means, as the numbers talk about it, 427 out of the 500 systems, 85% of all the systems are now running on Intel processors and coprocessors. The ones that are new, welcome to the list, as they say. Out of 114 of those, 111 are using Intel. That's 97% of new systems. What this, to us, is a very, very heartwarming acceptance of the work we've tried to do, incorporating feedback from the user community, from our partners, on what's the right path forward. If you look at the middle chart, that's the exciting frontier that we started to see a few years ago around this notion of acceleration of coprocessing as we ran up to kind of energy efficiency challenges and workload diversification, and wanted to look at architectures that could effectively address the needs of a diverse set of workloads. What you see on the list, and it's maybe a little bit hard to read from the back, there's the gray bars are CPU-only flops, or gigaflops actually. The light green is CPU plus GPU. no pun intended on the colors, and then the blue is the CPU and the coprocessor from Intel. What you see are two things, and both are fairly remarkable. The first thing you see is, starting about 2010-11, the notion of adding acceleration became quite important and a mainstay. Some of the very large systems deployed it. The coding community started looking at it seriously as the future. And you start to see the number of flops delivered in the top 500 beyond the gray bar of CPU increase. And it's continued to do that. What is the second thing is that the coprocessor line, which is the blue bar, which, if you recall, was the introduction of the Knight's Corner, the first Xeon Phi product in late 12, which shows up as a very tiny little blip, if you will, on this line. Ever since then, deployed for the first time in 2012, ever since then, has steadily grown and delivered more flops to the top 500 than any other co-processing or acceleration technology. That, again, is a great sign of the quality of the technology, but more importantly, the approach that that technology has taken in order to continue to deliver to user needs going forward. So on the right, the box on the right then is kind of a synopsis, a very short synopsis of the list that came out this morning. There are two number ones. The number one system in the world in China that we were so proud to be part of when it was announced retains its number one position. And then, consistent with that graph that I just showed you, the Xeon Phi, Intel Xeon Phi coprocessor still delivers more peak than any other co-processing technology on the list today. All of this sounds good, but in a very personal sort of way, the thing at the bottom, the statement at the bottom, is probably, as a community for us, the most rewarding thing, which is what is effectively and real use of these kinds of supercomputers and its value to us. The Praise ISC Award that was announced for a wonderful piece of work that took an earthquake simulation code and showed its scaling with optimization on the LRZ, an Intel-based LRZ supercomputer, supercomputer at LRZ, I should say, based on work that was done in Munich, shows that what has happened effectively is that the utilization of the efficiency of these architectures has gone up significantly. So where in the past people have shown a petaflop of real use, we're not talking peak, we're not talking some fancy speeds and feeds numbers. We're talking about a petaflop of real science, of a real application running. In order to do that, in the past, power systems have done it with deploying about 7+ petaflops of peak. Today, on the LRZ system, as it was demonstrated in this paper, you can get that same petaflop of peak deploying about 3 petaflops, sorry, 1 petaflop of real application performance, deploying only 3 petaflops of peak. So a doubling of the efficiency, and that is a very welcome news, because inefficiency is just in many ways money thrown away, from the equipment to running the equipment. So all in all, it was a very good list because it took us forward along many vectors, not just in hardware, but also in the ability of software to effectively use these hardwares, these various kinds of capabilities we all collectively work to put in our systems and get real use out of them. So if you look back at this 20th year of the Beowulf cluster, the year that it was democratized, the revolution started, and look at what has happened in the last 20 years, the dollars or the dollar money per flop has gone steadily down by about 15,000x. If you go back to the early years of 1994, when the Beowulf cluster was first powered by a DX 100 megahertz DX4 Intel processor, to what is packed in the current generation of Xeon Phi, it is roughly about a 15,000x 15,000x reduction in the dollars per flop. What that has done is really the chart on the right. Not only has it enabled greater and greater levels of pioneering science, but it has brought high-performance computing into the mainstream. And we are all beneficiaries of that, either as someone who benefits from the output of those, whether it's drug discovery, whether it's our financial markets, whether it's weather and climate modeling, to those that actually deliver or do through our work actually make it a profession and find our intellectual property going into it and serving an economic use. So it's no longer that tremendous reduction in cost has democratized HPC in a very fundamental way. And really the key question is, what's going to happen next? What's coming beyond this? Do I just take that 15,000x line and continue to draw it? And do I just have more pictures of more kinds of applications that we've known of, many of us are working on, and we can identify as needing more compute power? The answer to all of that is yes. But in our view, something much more fundamental has already started and is going to accelerate over the coming years. And that starts with this box on the left called new usages. This isn't to say that everything, all the applications that we've been working on get thrown away or forgotten. What it really means is almost implicitly, high-performance computing, or the art of modeling and simulation, becomes implicit and embedded into everyday workflows of people that would never, ever even realize that there was a high-performance computing application or a computer working on their behalf. The act of putting a 3D print button on an application is a very good example of this paradigm shift. Because what it does is it immediately energizes a workflow in which, at some part of the process, what you are trying to print is modeled and then transferred into the physical incarnation. That in itself, that capability to someone who just thinks of it as another dimension of printing, is a huge step forward in embedding HPC into a fundamental transaction without ever realizing that it is explicitly there to be commanded. The second one is new access mechanisms. As much as HPC has become more accessible, more programmable, it is still not to the level of a service. And through mechanisms like the cloud delivery model, we are starting to see some very, very interesting communities develop, access communities develop, capability communities develop, where high-performance computing can indeed reach people that have never been able to reach it before, can affect people, can be used by people who lack the ability to use it before, and fundamentally for all of us grows the TAM for this wonderful marketplace. The third one, and if you have contact with or just have teenagers of your own that are entrepreneurial in nature, you probably have run across these things. There are new models for investing in high-performance computing. It is no longer the big government agency. It is no longer that big pharma company. It is no longer that big industry. It is now a completely disaggregated way and a completely heterogeneous way of funding developments which use HPC, and also funding, in some sense, the development of HPC, whether it's applications that can be quickly deployed as a SaaS service, or things that can be built using a community HPC service probably delivered as a cloud. Probably the best example of this is what we think of as the 1 million+ users, the next generation users of HPC, called the makers. Those who probably won't recognize, nor will want to recognize, that they are using or dependent on something called HPC. Yet they are creative, they want to get together, they want to find innovative ways to fund their pursuit, to get the results out, which in many cases includes modeling and then creating physical objects. And in many ways, they are driving changes into HPC, the way HPC is delivered, the HPC is programmed, and in fact, financially even thought of as a commodity in the fabric of productivity than it has ever been before. So HPC's next stage looks a whole lot more exciting, a whole lot larger, and in many ways, a whole lot more different than it's ever looked if you look at the rear view mirror. So what do we do with this change? That's the question we at Intel ask ourselves. That's the question, the answer to which we hope to find in conversation and in collaboration with partners like you sitting in this room. Many have said, maybe with all these changes, supercomputing is the dinosaur. It's extinct. I can't tell you how many panels I've sat on or how many questions that have been put to me along the lines of, it's the big things on the top. Will they ever be used again? Can they be funded? Is it getting too hard? Is there any value there other than governments investing in it for national security and other reasons? The answer is quite fundamental. The technology that the high end of HPC or supercomputing delivers has impact well beyond just the supercomputing segment. If you look on the right, for instance, at the performance waterfall, the waterfall benefits of investing in new methods, whether it's hardware architectures, down to circuits, down to software models, down to applications, the presence of the supercomputing segment at the top is a tremendous innovation driver. What we see is the number one, as you see on the right, top 500 system to a single socket driven by advances in Moore's law. In 6 to 8 years, the number one system in the past has gone to the number 500 system. In fact, depending on which year you look at, it could be less or even more. Sometimes an entire half the list refreshes in 2 years. In fact, this list, we are at about 100 some, as I said, of new systems, which means 100 some of systems that were there last time are no longer on the list. That's how fast it changes. But what is most important is some of the things that are pioneered there, whether it's on packaged memory or fundamentally even something like a programming technique like multi-threading, then gets rapidly cured, hardened, broadened, and deployed in a much broader set of compute and communication products, including HPC itself. So we see this, the investment in the high end, the investment at the edge, the investment at the leading edge to be a fundamental driver, a place to invest and a place to double down and solve some of the challenges coming up on our horizon as we continue to push for more and more capability in the future to meet those emerging and growing needs. This is what I call this innovation, the system-level innovation at the top, and then I decided maybe at the top isn't the right way to describe it. The right way to describe it is from the top. What it means really, and this is something we at Intel have been engaged in for a while, is this notion of holistic design. Yes, many know us as the chip company. We are, at the end of the day, best known for our silicon products. But those silicon products, whether they're CPUs or storage or memory or whatever we build in fabrics, go into a system. The system is what is deployed to solve real end-user problems. Going forward, whether it's processors, whether it's interconnects, whether it's memory and storage, all of these have to be designed in concert, to work as a well-balanced system, and then designed and developed in concert with the software that runs on these systems. It is a large-scale, multidisciplinary, collaborative problem, which is why it takes more than one company, more than one segment of the industry to work together in order to realize these innovations going forward. One of the examples of such innovation from our perspective, which I'm very, very excited to announce, is the details of the Knight's Landing processor that we kind of hinted at and have gradually told you about over the last 6 to 9 months. What's Knights Landing is essentially the next generation of the Xeon Phi product. It is, for many of you that may not recall it or may know it already, if you're intending to deploy it, it is a self-hosted, it is a CPU. It is no longer used, can only be used as a coprocessor along with the host CPU processor. On the chart here, you kind of see the system, a mock-up of a system architecture. The specifics of it are very, very impressive. If you look at the compute side, it has highly energy efficient IA cores where the microarchitecture has been enhanced for HPC. In particular, enhanced for thread count, 4 threads per core, and 512 wide, what we call AVX or vector extensions for SIMD. The single-threaded performance, in order to keep AMDAL in balance, is about 3 times of what it is in the current generation product. In a single product generation, a 3x improvement in the single-threaded performance of the cores in Knights Landing compared to Knights Corner. And from a software perspective, it's binary compatible with the Xeon processor, which means the same, not just the same applications, but the same set of tools, the same shrink-wrapped operating system. All of those can run seamlessly, making it a very, very easily deployable solution in a software infrastructure. In order to keep this wonderful compute engine fed, it has been armed with an on-package, very fast memory. The wonders of packaging and integration, as you can see in the picture, is you get to do some very interesting memory innovations close to the compute engine. So you can get the bandwidth without spending the power. In particular for Knights Landing, we'll have 16 gigabytes of this very fast, very, very highly efficient memory on the package itself, backed up by DDR4, just like a standard Xeon socket would do today, to give you capacity beyond 16 gigabytes. The on-package memory will come with 1/3 the space that otherwise that DDR would have taken, 5 times the bandwidth of DDR4. For all of you that have labored extensively to write code to hide your memory latencies and suffered at the diminishing bytes per flop curve, this is a time to rejoice. 5 times the bandwidth, but not by running more pins or running the chip hotter, but 5 times better energy efficiency of that bandwidth. So all in all, a phenomenal compute engine that gives you 3+ teraflops in one package. And this isn't science fiction. It's going to be available in commercial systems, deployed in commercial systems, doing real work in the second half of 2015. We are very, very, very excited with where this is. We are very excited with the excitement of the community around this product. And we are very gratified to see some of our hypotheses around the value proposition of programming productivity and performance coming true in the voice of our customers coming back to us. So stay tuned. There'll be more as we talk more about Knights Landing and its revolutionary impact on taking the world forward on many core. If I stopped here, many of you would say, wait a minute, Raj, you didn't quite talk about this one thing that's staring out at us from yellow. It's called the integrated fabric. That is yet another tremendous advancement driven by the wonders of integration. What we are announcing, what I'm announcing today, is the Intel Omni Scale Next Generation Fabric. It is designed for maximum scalability. It is designed for systems that sit in a single or a couple of racks to very large-scale systems, which have complex topologies and different kinds of packet load rates and packet size rates to transfer. It has a rich set of programming models. We at Intel believe that you can't just throw legacy away because something sexier is on the horizon. It'll support MPI. It'll support MPI very, very efficiently, along with keeping the capability open to support next-generation programming models like PGAS. We will offer it in multiple configurations to allow OEMs to pick and choose the best densities, the best topologies, and in many cases, the best approach to solving a total compute capacity problem. And then finally, we will offer an end-to-end solution. As you can see at the bottom, complete from host side, like PCIe adapters, edge switches, director systems, all equipped with our silicon photonics technology to ensure that we have the best of class speeds, the efficiency of photonics from a cost perspective, and the energy efficiency of photonics to drive these extremely fast interconnects in the HPC system. The integration is started. It will first show up with Knight's Landing, and then subsequently on a 14-nanometer generation Xeon processor. And from then onwards, you can expect Intel to always have an integrated offering of the Omni Scale Fabric with any of the compute processors we build. We think it's fundamental. It changes the game because it allows us as a community to do things that we could have never done within a power, performance, and a cost envelope. So with that, I'm tremendously excited with the combination of what Knight's Landing will do, our continued innovations in Xeon, and in particular, the ability to bring the Omniscale Fabric as soon as in 2015. Again, not a science project at some point in the future, but in 2015 on a very specific product line to the marketplace. The future then is here. I've said twice now 2015, but it's best not to take it just from me, but look at what people are already doing with these technologies. Very, very proud to announce, and many of you have probably seen this, the announcement in April from NERSC on a system called Quarry, which is 9,300 Knight's Landings. No, this is not about a system which a part of it has Knight's Landings, or it's a Knight's Landing with every Xeon in case most of the codes are on Xeon. This is the future forward path built all on Knight's Landing. Almost 30 petaflops of peak. As you can see from both Mr. Binkley and Mr. Dosanjh, they made this selection based on two things. The first is their community, their users. Are they going to be able to use the system and get their work done? Is this the best choice for them? And I think you can see that in Sudeep's comments. We'll provide a platform for transitioning our very broad user community to many core architectures. The second was this investment the right long-term direction? And as you can see from Mr. Binkley's comment, as they look at more and more users needing more and more performance through many core, they believe that this investment path, which is not just in building the system, but in energizing an entire software community to write more and more parallel code on these architectures, is the right investment. We think this is a tremendous, tremendous voice for the value proposition that these technologies bring. And in the very near future, you will start to see more of these. It is therefore our joint responsibility, we believe, to not just bring these architectural facets to reality, but also work with the community in order to ensure that software is ready to take advantage of all these capabilities. And in so doing, this year, we went on a labor of love as we call it at Intel, around modernizing, helping the world modernize their code onto these architectures. We called them the Intel Parallel Computing Centers. We started, Bob, when was it? About 6 months ago? October of 2013. We put our first call out. The notion was to partner. This wasn't to just go set up our centers. This was to partner with the brightest brains who were motivated to take their applications forward and see what value these new architectures could bring, to work with them and get these codes modernized, algorithm learnings generated, so future algorithms could then be modified to make best use of these architectures, and finally give us the feedback so that we could best improve these architectures going forward. We've got more than 30 of these up and running since October of 2013. We've been overwhelmed with the interest and the quality of applications to be part of these IPCCs, as we call them. And we will continue to do this program in 14 and 15. In fact, if you have an interest, you can go to the website and apply today. We see this as fundamental. It's fundamental to continue to move the industry forward. We also see it as fundamental as our responsibility to ensure that the investment we make is best suited, used, leveraged, and at the end of the day, value recovered from the user's point of view. So all in all, we believe that this has been a tremendous year, but only the tip of the iceberg in many ways for the era of many core to come. We made some tremendous progress in taking visions, things that were on foils, and we said sometime in the future, into real products like the Knights Landing many-core processor, the first many-core processor, and the integrated high-performance fabric called Omniscale. And in partnership with you, with the community, moving the software forward, both at the system level and at the application level, along with tools and libraries, to best ensure that the ecosystem around stays vibrant, stays productive, and most importantly, has years and years more to celebrate such ISCs with wonderful achievements. And with that, thank you very much.